Okay, let's dive into this. From the packed stadiums
Huh.
in the sunlit pitches, where every goal can turn a fortune and, well, every foul can cost it all.
Yeah, dramatic stuff.
And today we're looking at how AI is trying to get a handle on predicting all that drama.
It's fascinating, isn't it? You've got this, like, beautifully unpredictable game meeting these really sophisticated models.
And we have a perfect example, a match analysis report.
Right, from the Gambler's Rune project. It's using something called SmartBet AI technology.
Exactly. So it's not just theoretical. This is them applying it to a real upcoming MLS match. Gives us a proper look under the hood.
And the match is St. Louis City SC versus Los Angeles Galaxy.
Okay, St. Louis versus LA Galaxy.
Scheduled for June 14th, 2025. It's at City Park. That's in St. Louis.
Gotcha. Time.
4:30 p.m. Eastern Time, 16:30 EST.
And they even get into the weather forecast in this report, which I found kind of interesting.
Well, yeah, what's it looking like?
Pretty variable, actually. 81 degrees Fahrenheit, cloudy, potential for a couple of showers, maybe even a thunderstorm.
Okay. Sounds potentially disruptive.
And humid. 76% humidity, 71-degree dew point. Wind, southeast 6 miles per hour, but gusts up to 16.
Wow.
And a 65% chance of precipitation overall.
So, yeah, not exactly ideal conditions, perhaps. That alone could throw a wrench in the works.
Definitely something the AI needs to consider, you'd think.
Yeah.
The report also flags injuries.
Right, key personnel stuff. What's the status?
For St. Louis, Joachim Nilsson. He's listed with an other injury type.
Vague.
Yeah, exactly. And expected return is unknown.
Okay. And for the Galaxy?
Couple things. Edwin Cerello, he's out due to yellow card accumulation.
Suspension. When's he back?
Expected back June 26th, so he misses this one. And then Ricard Puig.
Oh, Puig. Big player for them.
Yeah, he's got a cruciate ligament injury. Return date also unknown.
Oof. That's a significant absence. Losing a player like Puig, that really shifts things, potentially. You wonder how the AI weighs that.
Well, that brings us to the AI system itself. SmartBet AI. The report calls it a comprehensive prediction engine for MLS.
Okay.
And it mentions this hybrid architecture. What does that actually mean in practice?
Right, hybrid. It basically means it's not relying on just one method. It's combining different approaches.
Like what?
Well, typically it means mixing, say, traditional statistical models, things that are good at finding known patterns, like goal scoring rates, with machine learning techniques.
The ML stuff.
Exactly. Machine learning can often find more complex, maybe less obvious relationships in the data that the simpler models might miss.
So it's trying to get the best of both worlds.
Pretty much. Using different tools to look at the problem from slightly different angles, hoping for a more robust prediction overall.
Okay, got it. So our mission then, for you listening, is to unpack this report. We want to understand these different tools the SmartBet AI is using. See what factors it seems to be focusing on based on what's in the report.
Right.
And ultimately figure out what it's actually predicting for this specific St. Louis versus LA Galaxy game. We're trying to pull out the key insights for you.
Exactly. Where should we start? Maybe with one of the more established statistical methods they mention.
Sounds good. They talk about a dynamic ELO rating.
ELO.
You know ELO from chess, obviously. How does that work for a whole soccer team? And why dynamic?
Yeah, it's the same core idea. It's a way to rate a team's relative strength based on who they win and lose against and the strength of those opponents. You gain points for beating stronger teams, lose points for losing to weaker teams. The dynamic part just means the rating updates after every single match.
So it reflects current form. Sort of.
Exactly. It's trying to capture that momentum, that current trajectory. The report actually gives the numbers going into this batch.
What are they?
St. Louis is sitting at 1454.09.
Okay.
And LA Galaxy is a bit higher, 1485.97.
So based purely on the ELO history, the Galaxy look marginally stronger coming into this.
According to that specific metric, yes. It reflects their results leading up to this point relative to their opponents. But, it's just one piece.
Right. What else is in this hybrid mix?
A big one they mention is Poisson regression.
Poisson. Okay, that rings a bell from, sports stats discussions. It's about goals, isn't it?
Precisely. Poisson distribution is really well suited for modeling counts of events that happen somewhat randomly over a fixed interval, like goals in a 90-minute soccer match.
Makes sense. Goals can feel pretty random sometimes.
They can. So Poisson regression tries to estimate the average rate at which each team is expected to score.
Based on what factors? What goes into that calculation?
The report implies it uses quite a few things. Recent form, attacking strength versus the opponent's defensive strength, definitely home field advantage.
Which St. Louis has here.
Right. Plus those injuries and suspensions we talked about, the ELO ratings themselves, and interestingly, even external factors like betting market odds.
Oh, so it looks at the betting lines too.
Seems so. Which kind of incorporates the wisdom of the crowd, or at least the market sentiment, into the model. All that gets crunched together.
Okay, so crunching all that.
Yeah.
What's the standard Poisson prediction for this game? For the goals?
The summary section shows the standard model predicting 1.4 goals for the home team, St. Louis.
1.4. Okay, and for LA?
For the away team, LA Galaxy, it predicts 1.26 goals.
So very close. A
Yep.
slight edge to St. Louis in terms of expected goals, but generally predicting a tight, low-scoring affair.
That's what the base Poisson model suggests, yeah. But then they do something else with it. They talk about bootstrapped Poisson.
Bootstrapped. What does that add?
Bootstrapping is all about understanding the uncertainty. It's a statistical technique. Instead of just giving you that single average number, like 1.40, it involves running lots of simulations based on the model. Effectively, you resample from your data or your model's outputs many, many times. Here, they did 1,000 simulations.
Okay, so like simulating the goal process 1,000 times based on those estimated rates.
Exactly. And by doing that, you don't just get the average, you get a sense of the range of plausible outcomes. How much variability is there?
Right, because it's not always going to be 1.4 goals.
Never. So the bootstrapped average predictions are actually very similar. 1.37 for home, 1.29 for away. Almost the same.
Okay. So where's the big insight from bootstrapping then?
It's in the confidence interval it generates. The report gives a 95% confidence interval for the total goals scored by either team in this match.
And what is it?
It's, brace yourself, blast 0.0, 4.0.
0 to 4 goals.
For either team.
Yep. That's the 95% confidence range based on their bootstrapped simulations.
Wow. Okay, that really puts things in perspective. So while the average expected goals are low, around 1.3, 1.4, the model acknowledges that, statistically speaking, based on past variability in the model itself, a scoreline involving anywhere from 0 up to 4 goals for a team isn't out of the question. It absolutely nails how much randomness, how much potential deviation from the average exists in soccer. That average prediction is just 1 point in a much wider range of possibilities.
That's a huge takeaway right there.
Yeah.
Okay, so that's goal prediction. But the system also looks at the overall result, right? Home win, draw, away win.
Yes, exactly. It uses separate machine learning models, specifically classification models, for that task.
Classification, meaning they try to assign the match to one of those categories: win, draw, loss.
Precisely. These models look at different features again, probably things like form, head-to-head results, home-away splits, maybe those ELO ratings, injury impacts, and learn patterns that tend to lead to one outcome over the others.
And what did these specific ML models predict for St. Louis versus LA Galaxy? Does the report say?
It does. It says the models they use, and they likely use several different types of classification algorithms to get different perspectives.
Right.
They all independently came to the same conclusion.
It was
a home win for St. Louis City SC.
interesting. So multiple different machine learning approaches all pointed towards St. Louis winning the match.
That's what the report indicates, yeah.
Okay. And then there's another term mentioned, stacked ensemble prediction. What's that about? Sounds complicated.
It's actually a clever idea. A stacked ensemble, or stacking, is a way to combine the predictions from all those individual models you just ran.
Now,
You basically train another model, the meta learner, whose job is to figure out how to best weigh the predictions from the first set of models.
so it learns which models are usually better in which situations.
Kind of, yeah. Or just how to blend their outputs to get a potentially more accurate, more robust final prediction than any single model could achieve on its own. It's like having a committee of experts and then a chairperson who knows how to synthesize their opinions.
Okay, that makes sense. And the result from this, stacked ensemble for our match.
It also predicted a home win.
So the individual classifiers said home win, and the model combining them also said home win. Seems like a strong signal from the ML side.
It definitely points that way, yes.
All right, so let's recap. We've got Poisson models giving us expected goals, with bootstrapping showing a massive range of uncertainty around those averages.
The 0-4 range.
Right. And then we have multiple machine learning models plus a combined ensemble model, all predicting a St. Louis victory.
Correct.
How does the system put all of this together to give, like, a final probability? Does it just go with the ML prediction?
No, and this is where it gets really interesting and brings back that uncertainty aspect. It uses Monte Carlo simulation.
Okay, Monte Carlo, I've heard of that.
Oh,
How does it apply here?
it's another simulation technique. They essentially simulate the entire match thousands of times based on the underlying probabilities, specifically those expected goal rates we got from the Poisson models.
So like playing the match over and over on a computer.
Exactly. In this case, the report says they ran 10,000 simulations of this specific match.
10,000 times.
Yep. For each simulation, it randomly generates a number of goals for St. Louis and a number of goals for LA Galaxy, following those predicted average rates, like the 1.37 and 1.29 from the Bootstrap Poisson.
Okay.
Then, after running all 10,000 simulated matches, you just count them up. How many finish as a home win, how many as an away win, how many were draws.
Ah, and those counts give you the probabilities.
Precisely. It translates those underlying goal expectancies and their variability into outcome probabilities.
So what did the 10,000 simulations show for this game?
Okay, here are the results from the report.
Lay it on me.
A home win, St. Louis winning, occurred in 40.11% of the simulations.
Okay, 40%, so the most likely single outcome?
Correct. But an away win, LA Galaxy winning, happened 33.43% of the time.
33%.
No.
Still very significant.
Absolutely. And a draw occurred in the remaining 26.46% of simulations.
26%. Wow. Okay, so this is crucial. Even though the ML models predicted a home win,
Right.
the Monte Carlo simulation, which is grounded in those goal probability distributions, shows that while home win is the most probable result at 40%, an away win at 33%, and a draw at 26% are still very real possibilities.
Exactly. It's not saying home win will happen. It's saying it's the most likely of three possible outcomes, but the other two aren't far behind at all. It really quantifies the uncertainty.
It's far from a lock. That probabilistic view feels much more realistic for soccer.
I think so, too.
Oh.
The simulation also gives insights into the most likely score lines.
Oh, really? Like the final scores?
Yeah, based on those 10,000 runs, the single most frequent score line was 2-1 to St. Louis.
Okay, 2-1 home win. How often did that happen?
12.58% of the time.
All right, what was next?
Next most common was a 1-1 draw at 10.17%.
Interesting.
Then a 1-0 home win at 8.67%, and very close behind that, a 3-2 home win at 8.65%.
Fascinating detail. So mostly low-scoring outcomes, but spread across different results.
Exactly. It paints a picture of a likely close game with several plausible score lines.
This whole deep dive into the SmartBet AI report, it's really given us a glimpse into how complex this field is becoming, trying to model a sport like soccer.
It really has. It shows the effort to capture so many different things, doesn't it? You've got the long-term strength with ELO, the current scoring potential, and situation-specific factors with Poisson.
Right, including injuries, home field.
Then the pattern recognition strengths of machine learning for the outcome.
Yeah.
And finally, the simulations to bring it all together in a probabilistic way. That hybrid approach is key.
And using techniques like bootstrapping and Monte Carlo seems absolutely essential to force the model and us to confront the uncertainty.
Definitely. Seeing that 0.0, 4.0 goal range alongside the specific 1.4 prediction is quite humbling in a way.
It really drives home the range of what's possible on any given match day.
These models are powerful tools, no doubt. They can find patterns, estimate likelihoods based on vast amounts of historical data. But yeah, they're still models. A real soccer match has moments of individual brilliance, unexpected errors, maybe a controversial referee decision, just sheer luck.
Things that are hard, maybe impossible, to capture fully in data beforehand.
Exactly. The things that make us watch, really.
Which leads us perfectly into a final thought, something for you, the listener, to chew on after exploring this report with us. We've seen this incredibly detailed analysis, specific models, tons of factors considered, probabilities calculated down to the 100th of a percent. So the question is, how do we square this highly sophisticated, data-driven world of prediction with that fundamental, beautiful, sometimes maddening unpredictability, that randomness that makes watching a live soccer match so compelling, where one moment, one deflection, one unexpected event not fully captured by any model can change absolutely everything?
That's the million-dollar question, isn't it? How do prediction and reality coexist in sports?
Something to ponder, for sure. It's been a really fascinating look inside the AI black box for sports betting and analysis.
Absolutely. A great deep dive.